everyone, this video is about the Chapter 2 notes for Math 95, and in this chapter we're talking about combining like terms, distributive property, and evaluating expressions. And as we get into this, often students remember at least some of this, so hopefully it won't be anything too stressful and new for you. And I've taught this chapter a couple different ways over the semesters that I've taught it. And this semester I'm using an approach that's really a very hands-on approach. And you can kind of adapt that to whatever you need yourself. I have it set up here so you have little items in front of you, so you can actually see it hands-on. And if we were in a classroom during a regular semester when we could use objects, instead of paper clips and pennies and Lego pieces, I would have red blocks and blue blocks and green blocks in front of you. Okay, so that's kind of what my ideal would be, but I'm trying to adapt this for what you might have at home. And again, if you don't have some of these, just either substitute something else or just draw it on a paper or whatever you would like, whatever works for you, okay? So as we're going through this today, our special rule that we have to follow is that different types of items can never be combined together. So if I have 10 paper clips and 3 pennies, I can't just say I have 13 items. I can't put those together because they're different types of objects. Okay, so that's kind of what we're going to be thinking of today with our items, and then it's going to relate to something with math rules. Okay, so what I'm going to do is I'm going to kind of start you out on a few of these, and then I'm going to pause the video and fill in the answers, and I want you to pause it and really try it on your own, okay? This is, again, really meant to be very hands-on, very much you discovering this. I promise not to leave you hanging, but it won't mean as much if you just watch me go through it. I want you to really try it, okay? But let's do the first one together. So we're going to have 2 paper clips, 3 pennies, and 1 Lego. So I am just going to draw. Here's my 2 paper clips, my 3 pennies, and I'll make my 1 little Lego block here, okay? Now, we know that we can't say, oh, we have 6 things, because we said the different types of items can never be combined together. So all I can say is that I have 2 paper clips, 3 pennies, and 1 Lego, right? 2 paper clips plus 3 pennies plus 1 Lego. So again, I'm just going to, I'm going to write it over here again. So let me put it in another color. So just so we can kind of have these two next to each other. So here are my lovely paper clips, my 3 pennies, and my 1 Lego brick. All right, now I have some more items I'm going to put in front of me. Now I'm putting in front of me 3 Legos, okay, 2 pennies, and 4 paper clips, okay? So we can't just say, oh, we have this big pile of items. What do we have to do? How can we combine the first items and the second set of items? So in other words, I can't just shove all this stuff together, right? But what I can do is I can say, well, I'm going to take these paper clips. I can't combine them with other kinds of items, but I can combine them with paper clips here, my sad looking little paper clips. So I could combine those, right? And I can combine these pennies with these pennies. And I can combine this Lego with these 3 Legos, right? I can't combine Legos with pennies or paper clips with Legos, but I can combine Legos with Legos and pennies with pennies and paper clips with paper clips. So what can we do to combine the first set of items and the second set of items? Well, we can combine items that are the same, right? So in other words, I can say paper clips with paper clips, etc. Okay, how could we write the result? Well, we had 2 paper clips, and then we had 4 more paper clips, so we have 6 paper clips plus we had 3 pennies, and then we had 2 more pennies, so altogether we have 5 pennies. Plus we had 1 Lego, and then 3 more Legos, so now we have 4 Legos. Okay, so we couldn't, again, we can't just say we have a bunch of stuff. We're only combining things that are the same type. Okay, and you might think, what in the world does this have to do with math? But we're working toward it, don't worry. Okay, just have some faith for a little bit that we're going to get there. So again, depending on how hands-on you like your learning to be, you can draw pictures like I did, or you can actually have these items out and really have them in front of you and be moving them around, and you can see how these piles go together. Okay, so I want you to do this a couple more times. So you're going to do the same idea with number 2 and number 3. Okay, so you're going to have your paper clips, your Legos, your pennies. In number 3, we add in a 4th item, markers. So we have, in number 2, I have 2 groups of things. I have this group, and then you're going to figure out how many you have all together at the end, how you can combine those, remembering that you can only combine things that are alike. And then here I have 3 groups of items, and you're combining those. I'm going to see how we can combine them. Okay, so I'm going to pause the video for a minute. I want you to pause it also. Try both of those, write down your answers, and then start the video again to check your work. Okay, so hopefully you had time, you gave yourself time to stop the video and try these. And so I drew them out for the first one here. Sadly, while I was gone, my paperclip drawings did not get any better. But we have 5 paper clips, 2 Legos, and 4 pennies. 1 Lego, 3 pennies, and 5 paper clips. So it doesn't matter if paper clips were listed first or last. I know I can put those together, right, and have a pile of paper clips. So if I have 5 and 5 more, I have 10 paper clips. I have 3 Legos, and I have 7 pennies. Now I put plus in here like we had in the last time. You could have just had commas between them for now because it didn't really specify. And then here we had 3 groups of items. Now, again, you are more than welcome to have them out in front of you, to draw them whatever you wanted. I think you're probably starting to see how this works though, right? We can take the Legos and combine those. So I have 4 Legos, 1 Lego, and 2 Legos. So 4, 5, 6, 7 Legos. Then I have 7 pennies, 4 pennies, and 3 pennies. So 7 and 4 is 11, plus 3 is 14. And then I have 2 paper clips. Now there are no paper clips in this middle group, and there are 5 paper clips here, so altogether that's 7 paper clips. And then again, markers, 3 markers here, 2 markers here, no markers in the last one, so 5 markers altogether. Okay, and again, you can put the pluses here or commas at this point, it doesn't really matter. Okay, now if you are a really visual person, we don't want to get into having to draw everything out every time. Something like this might also help you if you have different colors. You might also have learned at some point, sometimes people underlined Legos with 1 line and then something else they would underline with 2 lines, but this kind of color coding might also really help you as you are combining things. Okay, so now we move this back into a little bit more like what we're used to with math. So we're going to look back at question 2. So question 2 is up here, and this is where we had the 5 paper clips, 2 Legos, 4 pennies, 1 Lego, 3 pennies, 5 paper clips. We're combining them. Okay, so we're going to just replace the item names with letters we call variables, okay? You can say it means the same thing, right? Instead of Legos, Legos is a long word, I just want to call it X. So I have 5 paper clips. Paper clips I am calling Z. So I now have 5Z, 5 paper clips, okay? If I have a letter and a number, a variable and a number next to each other, it means multiplication. So I have 5 times Z, which is the same as having 5 of those. Okay, if I give you a $10 bill, and then I give you 5 of them, I've given you 5 times 10 or $50. So it has the same idea here. Plus 2 Legos. Well, Legos, I'm replacing Legos with X. So 2X. And 4 pennies, I'm replacing pennies with Y. So I have 4Y. And then let's go ahead and do the same thing for the second group. We had 1 Lego. Legos are becoming X. So 1X plus pennies are Y, 3Y plus 5Z. Okay, how can we write the combined amount? Now think back to when we had piles of items. I couldn't say, oh, I have, 3 pennies and 5 paper clips, that's 8 things. Nope, I need to keep them separate. So just like I could before combine Legos with Legos, now I can combine X with X. So if I look here, I'm combining these together, adding these together. So here's an X and here's an X. 2 plus 1 is going to be 3X. Then I'm going to look at pennies. Pennies is Y. And it doesn't matter, like even though Z was first here, it doesn't matter what order I start looking at them in to combine them. I can start with any of those variables. Here's a Y and here's a Y. 4Y, positive 4Y plus 3Y is going to be 7Y. And finally, Z's. I have 5 Z's and 5 more Z's. 5 plus 5 is going to be 10Z. Okay, this is how I have to write the combined amount. I cannot put it together because I can't combine X's, Y's, and Z's, just like I can't combine paper clips, Legos, pennies. I have to keep them separate. So if we just remember here, this is, from what we were seeing up above, this is Legos, right? X was Legos. Pennies is Y. And paper clips is Z. So I'm just writing those because let's check back with what we had up above. So we have 3 Legos, 7 pennies, 10 paper clips. This is what I had up here, 10 paper clips, 3 Legos, 7 pennies, right? So whether I'm working with the actual items, whether I'm drawing it, whether I'm just looking at the words, when I combine those, the same thing happens as when I have X, Y, and Z standing for whatever that item is. Okay, so that's really all X, Y, and Z do. They are variables. They stand in the place of a larger description, whether that's Legos or pennies or how much a hot dog costs or the length of the room, whatever it is, that's what X, Y, and Z stand for, okay? They're not this magical thing. It's just a letter, like a label that stands for something big that we're not going to write out all the time. Okay, so now we have these two. 4x plus 3y plus 2z. And then we have 3x plus 8y plus 7z. So in this case, we can't combine different variables just like we couldn't combine different items before. So let's figure out how many x's, y's, and z's we would have, and then how to write the total. Okay, and again, I'm going to pause the video. I want you to pause it and try to figure this out. When I say how would you write the total, as something plus something plus something, okay? Go ahead and try it and then start the video up again and see how you do. Okay, so once you come back, again, I used the color coding up here to help us. Anytime there was an X, I underlined it in light blue. If there was a Y, I underlined it in dark blue. And if there was a Z, I underlined it in the red color there, the magenta. So then here, this is not generally how we write it, but I was just asking you, okay, how many X's do we have? Well, we have 4 plus 3. So that's 7, 11 Y's, 9 Z's, and then this is how we would write it, right? 7X plus 11Y plus 9Z. You can write that in any order. You could say 11y plus 7x plus 9z, for example. But often, to be sort of the standard format, we write the variables in alphabetical order. So x, y, z. Now, again, hopefully you're understanding by now, we can't combine these, right? We can't say, oh, 27 something. Even though 7, 11, and 9 add up to 27, they're representing different groups of items. Okay, let's look at the next one. You order a box of blocks to be delivered to your house. You are expecting to receive the following. You're expecting to receive 3 red blocks and 2 blue blocks. By mistake, the company sends you 3 identical boxes of that. So you order 1 box of blocks. They send you 3. So let's draw what will be in each box. So I'm going to use my little colors up here. You can just label them or whatever you want. So in each box, I want a red block, another red block, another red block, and then 2 blue blocks, right? This is what I was expecting. 3 red blocks, 2 blue blocks. I'm just being lazy and drawing just the top, not making them 3-dimensional here. So then the second, so this is what I wanted, 1 box of that. Instead, I got 3 boxes, and each box has the same stuff in it. So each box has 3 red blocks and 2 blue blocks. Okay. How many of each color block do you have in all? Okay, so all together in that whole shipment you got of 3 boxes, how many blue blocks do you have and how many red blocks do you have? So pause the video for a minute and go ahead and fill those in, please. Okay, so we should have 3, 6, 9. 9 blue blocks and 2, 4, 6. Sorry, did I say blue? 9 red blocks and 6 blue blocks. Okay, so we could get that just by counting, just by looking at what was in each of these boxes, right? Well, what if I didn't draw it out? But I just knew that originally I had 3 red and 2 blue, right, in each box. I received 3 boxes. Okay, well, kind of like we did with our drawing. One way we could have gotten these numbers is to add. Okay, I could say for the red, I want to add 3 plus 3 plus 3. That's how I got my 9. And for the blue, I want to add 2 plus 2 plus 2. That's how I got my 6. Okay, well, the other way we can do it is related to this. Whenever I have repeated addition, if I add the same thing over and over and over and over, like 3 plus 3 plus 3 or 2 plus 2 plus 2, when I have repeated addition, then I can multiply. Okay, so let me just write over here. Multiplication is just repeated addition. Okay, so if I'm adding the same thing over and over and over and over again, a shortcut is multiplying. Now, if I were adding different things, if one box had 3 reds and another box had 2 reds, another box had 6 reds, I couldn't multiply. But since I'm doing the same thing over and over, so if I look at these boxes, I have 3 red blocks, and I have that 3 times. So I want 3 times 3, and that gives me 9 still. Blue blocks. I have 3 boxes, and each box has 2 blues. So 3 times 2 equals 6. Okay, so I could have added here, or I could have multiplied. So let's look at the next one. Selena has a cake recipe that calls for 3 eggs. So I'm just going to write this down here. 3 eggs, 2 cups of milk, and 1 cup of chocolate chips. Okay, she wants to bake 5 cakes for her Leadership Club bake sale. How many of each of those 3 ingredients will she need? So I want you to figure out how many eggs she's going to need altogether. She's making 5 cakes. How many cups of milk? And how many cups of chocolate chips? Okay. And you can use either one of those methods we just talked about, right? You can either add or you can multiply to get there. So go ahead and try that, okay? Then what I would like you to do is try number 8. So you're going to replace the ingredients in question 7 with variables, just like we did before, okay? Instead of saying 3 eggs, we're going to say 3A. Same thing for the cup of milk, same thing for the cup of chocolate chips. Then see if you can figure out an expression to show what the 5 cakes will need. Okay, try writing it out that says 5 times this, and then we'll work through that in a minute. Okay, so go ahead and pause the video, do number 7, and try to start number 8. Okay, so we're back to figure out about this cake. So she wants to make 5 cakes, and each cake uses this many ingredients. So we know one thing we can think about is if she needs 3 eggs for 1 cake, then for 5 cakes, she'll need 5 times that many, so she'll need 15 eggs. 2 cups of milk for each cake times 5, she'll need 10 cups of milk, and 1 cup of chocolate chips times 5, she'll need 5 cups of chocolate chips. So she didn't just multiply the eggs, let's say. She needs 5 times as many eggs and cups of milk and cups of chocolate chips. So let's move into using some variables for this. So eggs is going to be A, cups of milk is B, and cups of chocolate chips is C. So let's go ahead and write an expression to show what 1 cake would need. And if you think you know what this is going to be, then go ahead and pause the video and try that. So eggs are A, we need 3 eggs, so 3A plus 1 cup of milk, 2 cups of milk, and 1 cup of chocolate chips. So this is what 1 cake would need. Okay, now, if I want to find out what 5 cakes will need, I want 5 times this whole thing, and I cannot write it like this. I'm going to write it sort of the wrong way first, okay? I can't do this, because if I do this, this says 5 times this, but only the 3A is being multiplied by 5. So I would take 5 times as many eggs, but I need to also say 5 times as many cups of milk and 5 times as many cups of chocolate chips. So if I want to take this whole expression with more than one term and multiply it by 5, I need to put this in parentheses to show that, as we did up here, we knew that we weren't just multiplying one thing by 5, we're multiplying all of those by 5. So now, in this next step, we can simplify this using the distributive property. Okay, so the distributive property says that everything in this expression is going to get multiplied by whatever's outside here. So again, think about that cake, right? If I'm making 5 cakes, I can't just use 5 times as many eggs. I have to use 5 times as many cups of milk and 5 times as many cups of chocolate chips. So this 5, we often kind of draw little lines like this just to remind ourselves that this 5 gets multiplied by everything inside there. So 5 times 3A is going to be 15A, 5 times 2B is 10B, 5 times 1C is 5C. And if you think about what we had before, we said 15 eggs, 10 cups of milk, 5 cups of chocolate chips. And we know from before that we can't combine those because they are different terms. They're not like terms, so they have to stay separate, just like that. Okay, so that's a little, we'll come back to using the distributive property in a little bit, but that's like a little example of how the distributive property works. And now let's say we put out 2 paper clips. So here come my fancy paper clip drawings again. 2 paper clips. We put out 3 pennies and we put out 5 Legos. I'm just gonna make them little blocks this time. Okay, now we want to take away 1 paperclip, 2 pennies, and 3 Legos, okay? So we're not adding this time, we're taking those away. So I want to take away 1 paperclip. Okay. I want to take away 2 pennies. I want to take away 3 Legos. So I didn't just take away the paper clips and then, let's say, add the pennies and Legos, right? I took away all of these. So what do I have left then? Oops, it says how many of each color. This should say how many of each item. That was just, as I said, when we could do it in class, I used colored blocks, so I just missed switching that. Okay, so what do we have left? We have 1 paper clip. We have 1 penny left, and we have 2 Legos. So we subtracted 2 minus 1 for the paper clips, 3 minus 2 for the pennies, and 5 minus 3 for the Legos. So let's look at this. If we substitute variables in place of, the items in question 9, so we had 2 paper clips, 3 pennies, and 5 Legos, and we took away 1 paper clip, 2 pennies, and 3 Legos. Okay. Now, the reason we are doing this one is because I wanted to show you about subtraction. Subtraction is a little tricky with polynomials like this, with expressions like this. Okay. And we'll talk about this more later on in the year as well, but when we subtract something, right, if you notice, as I said, we didn't just subtract this first term. We didn't just subtract the paper clips. We also subtracted the pennies, and we subtracted the Legos, okay? So when I do this, I have to make sure that I'm subtracting each thing inside that parentheses. So 2x, I'm going to subtract 1x, right? So 2x minus 1x gave me 1x. 3x minus 2x. 3 minus 2 is positive 1. Oh, sorry, that's y. And then 5z minus 3z. So I'm going through this minus every time. So 5z minus 3z is positive 2z. And again, that goes along with what we had here. 1 paper clip, 1 penny, 2 Legos. Okay. So what we want to remember is that we cannot just take away the parentheses. So let me show you why not. Okay, so let's say I have my 2x plus 3y plus 5z, and I subtract 1x plus 2y plus 3z, and I don't put my parentheses there. I want to subtract this whole thing, or I just take them out as soon as I see the problem. Well, what's going to happen now is I have 2x minus 1x, but there's nothing saying that this 3y has to have this minus here, right? So I would have 3y plus 2y. It's a totally different problem. So I can't just take away those parentheses. Okay, I have to keep them there. And then, so I can use that subtraction throughout that whole expression. Okay, so I have some problems here for you to try. Let's see what I have here. I have 4 there, and then we're going to go on to evaluating expressions. So here are the distributive property. They're written out a little more traditionally. If you want to think of sort of a scenario in your head, again, think of like, this is what I need for 1 cake. I have 8 cakes, right? Or this is what I ordered in 1 box. I got 8 boxes of those. So all of these have to be multiplied. So you're going to multiply that 8 by both of those. Over here, you're going to multiply -7 by each of these in parentheses. Watch your signs. Okay, so think of this as a -5, because we know that -5 is the same as plus -5. So you're going to think about those. Now, these two, you're just going to do the distributive property. Here, you're going to do the distributive property, 2 different places, and then If you have like terms at this point, then you can combine them. Okay. And then in number 4, see how we have brackets and parentheses. You want to work from the inside out. So this one's a little tricky, but you can do it. You're going to distribute this first. Simplify what you have, and then later on, you might have to distribute this 2 through whatever is left. So try all 4 of these, okay? Go ahead and pause the video. I'm going to pause it and put the answers in, and then when you come back, you can check your answers, okay? And any of these that you're not sure about, I'll talk about them a little bit, but I won't talk about them too much, and you can ask me in class. Okay, so here we have these 4 questions, the answers to them. So the first 2, again, we were just distributing, multiplying, watching those signs. The second 2 were a little more involved. So number 3, -3 gets distributed through this first set of parentheses. -4 gets distributed through the second set. So again, watch your signs. Once I've done that, I notice there are 2 x values that I can combine and 2 constant terms that I can combine. So here's my final answer. -7x plus 34. And then here we have 5 plus 2. We had a bracket, x plus 4 times x minus 5 plus 3. So I start in the inside, right? Think about kind of doing parentheses. I mean, it's not exactly order of operations, but it's the same idea. But we do from the inside out. So I do this distributive property here first. 4 times x minus 20. So I rewrite everything else. Now, within this bracket, I can see that I have some like terms. I had x and 4x, and I have -20 and +3. So I can combine those. So I end up with 5x minus 17. Now here's one of those things where it looks very tempting to add 5 plus 2, but we have to distribute this first, okay? We always have to distribute that first to get rid of those parentheses or grouping symbols. So I distribute that 2 through. I get 2 times 5x minus 34, 5 plus 10x minus 34. You can see here that I underlined like terms, so I get 10x minus 29. Okay, and then the last thing we're going to do here, evaluating expressions. Okay, so we're going to go through a couple of examples that kind of get us into that mindset. And then we have a couple problems to do, and then we'll be done. Okay, so first of all, first example here, let's say you are looking at a website online where you can donate backpacks to kids who need them. Each donation is $10, and there's a one-time processing fee of $4 added to your transaction. So if you donate $10, you can donate 1 backpack. No matter how many backpacks you donate, there's a single fee of $4 for processing to help with this organization's fees, okay? So if I donate 1 backpack, what's the total here? Well, it's going to be the $10 for the backpack plus the $4 for the fee, so altogether it's going to be $14. Okay, so take a minute and pause the video and think about what you would get for the next 2, for 3 backpacks and for 20 backpacks. Okay, so for 3 backpacks, if we think about this, the backpacks themselves will be $30, and then there'll be this one-time fee of $4, so it's going to be $34 is my total. So this right here, just to remind us, is 3 times 10, right? $3, 3 backpacks times $10 per backpack. 20 backpacks. Well, the backpacks themselves, 20 times 10 is 200, so I'd spend 200 just on the backpacks, and then $4 more for that processing fee, so it's going to be 204. So again, this 200 came from 20 times 10, right? 20 backpacks at $10 each. So how did we find the total for these? Well, the first thing we did was to multiply the number of backpacks times $10. or $10 each, okay? So that's where we got the 200 or the 30 or the 10 here, right? This is really one backpack times $10. Then what did we do? Then we added the $4 to that, okay? So if we use X to stand for the number of backpacks donated, because as I said before, a variable is just a shortcut to stand for something. I don't want to write out number of backpacks, so I'm just going to call that X. Then we know we need to take that number and multiply it by 10 and then add 4. So let's write this as an expression, so using X. So take a second, pause the video, and see if you can write this out as a single expression. Okay, so we would have 10x, 10 times x, plus 4. There's my expression that shows how to find the total. Now, think about math as just being another language, okay? I could say in words, what I'd set up above in the example, I'm going to pay $10 per backpack, plus I'm going to pay an extra $4 one-time fee. Well, that's exactly what this says right here. It's saying 10 times however many I have plus $4. Okay, so now we're going to use this expression, which I'm going to rewrite here, to find the total cost to donate 17 backpacks. Well, we did this before without this expression, but we would say, how much does it cost for 6 backpacks or 8 backpacks or 20 backpacks, right? We could put anything in there. We want to know how much it's going to cost to donate 17 backpacks. We know X stands for the number of backpacks. So we are going to, in place of X, we're going to put in 17. So I now have 10 times 17 plus 4. 10 times 17 is 170. 170 plus 4 is 174. So when we have an expression with a variable, okay, again, because that variable stands for some value, in this case the number of backpacks, we can then plug in for it for whatever our number of backpacks is that time, whether it's 1 or 5 or 130 or whatever it's going to be. Okay, so let's start with the expression 5y minus 12. Can you think of a real-life example that could be described by this expression? So take a minute and think about that. You know, something's being multiplied and then something's being subtracted now. So there's not just one right answer, certainly, but, you know, maybe you're buying something, 5 pairs of sneakers, and you have a coupon for $12 off your total purchase, right? So if all the sneakers cost the same amount, here's your total, and then you would take $12 off. Right? This could be whatever you're, you know, there's lots and lots of different, doesn't have to be money, but lots and lots of different ideas or examples. So I'll leave that up to you. Okay, so now go ahead and pause the video and see if you can find the value of the expression when y equals 5. So you'll start out with 5y minus 12. Think about what you would get if y equals 5. And then, again, start out with 5y minus 12. See what you would get if your value of y was negative 3. Okay, so for this one, the value of y is 5, so I'm going to substitute 5 in place of y. This is saying 5 times something minus 12. Well, that something is 5, so 5 times 5 minus 12. Then I use order of operations, and so here, 25 minus 12, and then that is going to be 13. When I have y equals negative 3, so again, 5y minus 12, I substitute negative 3 in for y. I get negative 15 minus 12, which is going to be negative 27. Okay, example 3, very similar. We just have 3 different variables now. Okay, so go ahead and try that one. Okay, so this one, you know, same idea. We have 3 variables here, x, y, and z. We need to make sure we're just plugging into the right one. That's probably one of the challenges here, just making sure we have the right number in for the right variable. So 3 times x becomes 3 times 2. 4 times y becomes 4 times negative 5. And 10 minus 10 times z becomes minus 10 times 6. So I then multiply I then add and subtract from left to right and get negative 74. Okay, so now what we've been working with are expressions. They're not equations. They don't have an equal sign. So I just substitute in, get an answer out. Okay, what we're doing here, though, is very similar to when we use formulas, like an area formula. So an area formula is going to be an equation, but if we're just substituting it on one side, then essentially it's the same as what we've been doing. So let's say we want to find the area of a rectangular deck that has a length of 12 feet and a width of 9 feet. So if we look at the Math 95 reference tables, we find that the formula for the area of a triangle is A times LW. A equals L times W. Area equals length times width. So just like before, if I think of this, okay, this is a formula, and L and W and A all stand for something. I want to find what the A is, so I don't know that. But if I know a value for L and I know a value for W, then I can just substitute those in just like we have before, just like saying it's a value of X or a value of Y. So this, our information says the deck has a length of 12 feet. So length is going to be 12, and I'm multiplying that by the width of 9 feet. Okay, then I just go ahead and multiply those. I just substituted in for each one, just like we did above. So area equals 108, and it's going to be square feet. Remember that from other classes, right? When we have a rectangle like this, the area is the space inside, so we label that with units that are squared, square feet. Okay, let's do a couple more. So what I would like you to do is for 5 and 6, take a look at your reference tables, find the formula that does this, right? Finds the area of a triangle. So find the formula, and then you are given values for the base and the height. So you're going to substitute those in. Same idea here. Surface area of a cube whose sides are 4 inches long. So you want to find the formula that talks about surface area of a cube. And then the information you're given is that the sides are 4 inches long. So go ahead and try those two, and then pause the video, go ahead and try those two, and then come back and check your answers. Okay, so for the area of a triangle, your formula is area equals 1/2 base times height. So the way this works here is that your base and your height in the triangle, you don't really need to know all this, but I'm just going to kind of tell you the background of it, sort of. The base and the height of the triangle have to make a right angle. So we can call this side the base, then this would be the height. It's the straight up and down height, okay? It makes a right angle with the base. So this is my height here. It's not the slanted height. But you don't really need to know that. To solve this, all we're doing is we're saying, okay, 1/2 times B times H. Well, I know B, or base, is going to be 10, so I substitute 10 in for that. And I substitute 8 in for my height. Now I have 3 things that are being multiplied. So I actually, if they're all being multiplied, I can go left to right. I don't have to. Remember, the commutative property says that I can do this in any order. So I chose to just do 8 times 10 first for 80, because I know half of 80 is 40. If you had done it in another order, you could have said half times 10, half of 10 is 5, and then 5 times 8 also gives you 40 square centimeters. For 6, the surface area of a cube whose sides are each 4 inches long. So surface area means, you know what the area is of a side. Well, a cube is 3-dimensional. So surface area is if I'm covering all of those faces, all of those sides, the top, the side, all of those, oops, this is wrong too, with wrapping paper or paint or something. So I actually have a mistake in here, so let me fix this while we are going over it. This should be 6, not 4. Sorry about that. So if you look at the formula, you will see 6s squared. Okay, why is that? Well, the area of one face, one part of the cube, is side squared. Okay, if I have a square here, my formula for my area is going to be side times side, kind of like base times height, but in a square, they're all the same. Well, that's the area of one side. If you think about a die, or any kind of cube, there are 6 faces on it. So it's 6 times that area. So my sides are each 4 inches long. That goes in for the side length. I do my exponents first. So 4 squared is 16. And then I have to multiply these. So 16 times 6 is going to be 96 square inches. Okay, and finally, last one here, the volume of a cylinder. And we are given the diameter and the height. Okay, now, so a cylinder is like a soup can, right? Or a soda can, or whatever you want to say. So the volume is how much space is inside it. We have the height. So this is my height of 12 inches from here. The diameter is 8. So the diameter of a circle is all the way across. Oops. All the way across the middle of that circle. So if I were looking down at the top of that soup can, here's my center of my circle, the diameter is 8 inches. Okay. If you look at the formula for volume from your reference table, I don't expect you to know it by heart, but it's pi r squared times h. Okay. Actually, that's not right. Hang on. Oh, that's right. Area of the base times height. Okay, sorry. Second guess myself for a second there because I hadn't looked it up. So pi r squared times h. You see that their height is in here, but there's a radius in here, an r. We're not given a radius. Well, what we need to remember is that the diameter is all the way across. The radius is just halfway across. So if the diameter is 8, then the radius is going to be 4. Okay, and that's what I'm going to put in here. So now I get volume equals pi times 4 squared, right, radius squared, times the height, which is 12. So I get pi times 16 times 12. Okay, now there are a couple different things we can do here. We can say 16 times 12, get that, so that's going to be 12, that's going to be 36, this is going to be 16, so it's going to be 192 times pi. These are inches, volume is a cubic measurement, cubic inches. You can leave it like this, or you can, I'm just going to use my calculator over here because I don't want to, I was going to pull one up on the screen, but I'm afraid I might mess up my little recording thing there. So we can take 192 and we can use 3.14 for pi, right? We had talked about how it's really an irrational number. It goes on forever, but we call it 3.14. So we get 602.88. So either 192 times pi, you can just leave it as pi, or you can say 3.14 for pi, multiply those, and get 602.88. So that's how many cubic inches there are in this volume. Okay, so went a little bit off into the formulas, but again, you don't need to know those, you just need to be able to look them up on your reference sheet. And what I wanted to show you was that really we were doing here what we had been doing before with the expressions, right? Okay, there's an h in here, here's my value of h for this time. And that's really why we have these formulas, because you can use this for any cylinder. You don't have to reinvent the wheel for every cylinder here. You can just say, oh, in this case, h is 12. In another cylinder, h is 8. In another cylinder, h is 30. And then plug in whatever's there for that specific situation and get your volume. All right, so if you have questions on any of this, please make sure you email me or ask in class. Thanks.